So before we jump into some really lengthy videos on NMR, let's talk about the big picture with NMR. So there are two major pieces of information we're going to try to get out of NMR. So NMR here is nuclear magnetic resonance. If you've had an MRI, this is a similar technique. But what we're going to use is probing of the nuclei associated with the molecule to determine basically what's present inside the molecule. Specifically with hydrogen NMR, 1H NMR, where we're going to try to determine the number of hydrogens, or at least their relative ratios to each other, and the different types of hydrogen. So these are going to be the hydrogens basically different functional groups. How many different functional groups we have with hydrogen associated with it. Now, for carbon 13, 13C NMR, what we're going to try to do is determine the number of functional groups because that's going to tell us the number of carbons. Now, big thing NMR struggles with. First of all, we can't really do oxygen NMR. It does exist, but oxygen 14, which is the isotope of oxygen that's actually NMR active, like hundreds of thousands of dollars a gram, we're not going to do it. It doesn't exist in a reasonable quantity. So we're only going to look at the carbon and the hydrogen. Now, NMR is what's considered a medium to small length scale. So we are going to have issues with alcohols. Those hydrogens can pop off. So the hydrogens are labile. They're not going to give us a lot of information about what hydrogens are nearest them. Now, there are also a lot of exotic NMR techniques, and they have been developed over the years to kind of really basically make this analysis better. So big things are nosy and cozy spectra, and these 2D NMR plots where we look at carbon 13 versus 1H hydrogen. These are very useful plots. Unfortunately, they are what's considered expensive techniques. They take hours and hours to run versus a carbon 13 or 1H NMR. The 1D NMRs are cheap and take maybe 5 to 10 minutes. So at the organic chemistry level, we typically focus on the 1D NMRs, the carbon 13 and the 1H, because they're a lot easier to run, they're much easier to find, and there is a bit of skill associated with them. Now, that said, the complication with NMR is a lot of it is guessing and testing. So when we look at these NMR spectra, we're going to start making hypotheses and we're going to test them to the other pieces of information. So no one analytical technique is really sufficient for figuring out everything that's going on. We actually need what are generally considered the four main methods: carbon 13, 1H, mass spec, and IR. And those four techniques should give us a really good idea as to what's going on. So that's the big picture. Use the 1H to figure out the different functional groups and figure out how many hydrogen atoms are relative to each other, basically looking at the functional groups, and using the carbon 13 to figure out the number of carbon functional groups that are in our organic compound.